Hello all. In this video we will be discussing one problem in which we will determine the centroid and moment of inertia of the shaded portion in the given figure, which is a trapezium. Okay, so to determine the centroid or moment of inertia of this complex figure, we will first divide it into the known sections whose value it is easy to determine. So first we will break this into one right angle triangle. This will be your another right angle triangle. This is one rectangle and this is one semicircle. Okay, so this is first, second, third and fourth. For this I will only determine the horizontal centroidal axis of the entire figure and moment of inertia about horizontal centroidal axis IXX. Okay, so horizontal centroidal axis matlab I will need distance from y axis, so I will determine y bar and IXX. Okay, to determine y bar the formula will be a1y1 plus a2y2 plus a3y3 minus a4y4 upon a1 plus a2 plus a3 minus of a4. Now let us make a table. We have section, first column will be section, second will be the area and third will be the value of y, which is distance from x-axis. That way we can determine this horizontal centroidal axis, and last column let be a1. So your first section is a right angle triangle whose height is 120 and base will be 50. This will be the base because this rectangle is of 200. इतना 200 होगा, ये 150 में से इतना 100 गया, बचा आपके पास 50. The area of a right angle triangle is given by half into base into height. It comes out to be 3 into 10 to power 3. Then y means distance from x-axis. So for a right angle triangle you have h by 3. H by 3 will be 120 by 3, so 40, and ay comes out as 1.2 into 10 to power 5. Then let us consider second section, which is a rectangle of dimension 200 by 120. So its area will be 200 into 120 will be 2.4 into 10 to power 4. Y, which is distance from x-axis, will be given by again d by 2. So 120 by 2, 120 by 2 will be 60, and a into y, so 60 into 2.4 into 10 to power 4 will be 1.4 into 10 to power 6. Again you have third section, which is right angle triangle whose base is 50 and height is 120, so half into 50 into 120. The area will be same, 3 into 10 to power 3. It's again distance from horizontal axis will be h by 3, so h by 3 means 120 by 3, so it will be 40, and a into y will be 1.2 into 10 to the power 5, which will be same. And fourth section, which you need to subtract, so it needs to be deducted. You have a semicircle, so its area will be pi r square by 2, so it is pi into r is 100 square by 2. It comes out to be 1.57 into 10 to power 4. Its y is distance from x-axis, so distance from x-axis will be 4r by 3 pi. So you have 4r by 3 pi, r is 100, so it comes out as 42.44. So ay will be 6.66 into 10 to the power 5. On substituting all these values, this will be minus, this will be minus, and this will be minus. On substituting all these values, we will get y bar equals to 68.11 mm. Okay, this will be y bar will be 68.11 mm. Now we have to determine the horizontal moment of inertia about its horizontal centroidal axis. So out of this Since the height of this entire figure is 120 mm, the horizontal centroidal axis will lie at 68.11 mm.